All right, guys, we're working on Unit 6, Lesson 4. We're determining reasonable answers. So we're going to be looking at rounding and using mental math to make sure that our answers that we provide for our story problems are reasonable. Please take notes as you watch the lesson. So here's our first story problem. How much change should be given if a $50 bill is used to pay for a $19.12 purchase? You would use estimation to check your answer for reasonable. Take 50, subtract 20, approximately $30 then. So just making sure that your answer should be somewhere near that. Now, if you actually worked it out, you obviously would get a little bit different answer. So when we actually work these problems out, right, we need to extend our decimals out and do the actual subtraction to see that our answer should be right on. So I'm just going to work this out all the way through. Do some borrowing here. 10 minus 2 is 8. 9 minus 1, 8. Put my decimal in. 9 minus 9, 0. 4 minus 1 is 30. So 30, 88. So right by our estimation is what we want to see. Okay, how many school buses are needed to seat 351 students if 39 students will be seated on each bus? You could look at this like estimation, like 40 times S equals around 350. So many 40s are there? You could look at this like 350 divided by 40. And again, just using that estimation. To check your answers. So as you guys work through that, you can pause the video, finish out that problem, and think about how that works through. Come back and we will talk about it. All right, welcome back. So when you look at this first problem, you should, or the second problem here, right, you should be thinking, well, 9, right? It's about 9, could be about 8, okay, just depending on how you look at this. You know, you could be thinking about 35 divided by just 40 because the zeros cancel each other out, and what that would be, or rounding. Okay, so let's take a look at Puzzled Penguin here. Puzzled Penguin, write the information on the board. Puzzled Penguin made a calculation error. There's a population of Sarah's, California, and a population of Claremont, California, and he says the difference is about 10,000. He estimated 500,000 minus 30,000 is 20,000. So what did he do wrong? Well, he underestimated one and he way overestimated the other. So if you look at this, right, he overestimated the 45 and he way underestimated the 34. He would get a more accurate answer if he just did used estimation of 45,000 and even subtracted 35,000, right? That would give me a better estimation of around 10,000, which is much more accurate. He could have done 45,000 minus 30,000 and even been closer, you know, than he was. So think about the difference between exact estimation and rounding, those kinds of things. Okay, so here we are on the homework. We've got some equations that we're going to solve. We're going to use estimation to check our work. So in a speed test, a computer took 12 and 4/10 seconds to complete one task and 37 and 8/10 to complete a more difficult task. How much time was needed to complete both? So we would do 12 and 4/10 plus 37 and 8/10. Okay, when we add those up, add those up over here, going top to bottom, keep our decimals in line. If we estimated, we might say 10 plus 40, so that's 50 seconds. I'm going to put the approximate sign, remember that, guys? Seconds. Okay, so let's actually add 4 plus 8. 12, carry my 1, 10, carry my 1, and so we found, oops, this is a 5. So it actually equals 50 and 2/10. So our estimation was really close. There, I'm going to abbreviate seconds again. Okay, going forward to walk to school, Pablo first walks half a kilometer to Tanya's house, then Pablo and Tanya walk 3/5 of a kilometer school. How far does Pablo walk? So what we're actually doing is 1/2 plus 3/5. Okay, we need to find that common denominator, and I'm going to use 10 as my common denominator because I know 1/2 is the same thing as 5/10, and then I know that 3/5 is equal to 6/10, so now I'm just adding those two up and then I'll simplify. If I was going to estimate, 3/5 is greater than 1/2, so 3/5 plus 1/2 needs to be greater than 1. So you guys see how I estimated? I just went, well, half plus 3/5. 3/5 is greater than half. Half and half would be 1/2. So something greater than 1. So 6 plus 5 is 11/10. Right? This is equal to 11/10. And if we simplify that down, because this is an improper fraction, we get 1 and 1/10. Okay? Each Saturday morning, Andy works 4 hours to earn $34. At that rate, what does Andy earn for each hour that he works? So we're going to take 34. We're going to divide that by 4. Why don't you guys pause the video and work that out? Also do an estimation problem for me. Figure out what we would actually estimate by. Okay, pause and figure out. Okay, welcome back. If I was looking at this, I would think about 4 times what gets me close to 34. Okay, well, 4 times 8 is 32. So about 8. Okay, so then I can put my 8 up here. All right, 32, subtract out, add my decimal, bring it down. 4 into 20 is 5, bring my decimal up. So 850. He gets about 850 an hour. Okay. So just thinking about how you can check for reasonable, right? Yuri competed at a race with 88 hundredths fewer seconds than Josie's time. Josie's time was 23 and 95 hundredths. How long did it take Yuri? So it's a subtraction problem. 23 and 95 hundredths minus 88 hundredths. Okay, if I was estimating, I might bump this up to 24 minus 1. I would get 23. Okay, so I'm going to end up somewhere in the 23s. I want you guys to pause the video again. I'll set the problem up out here to the side and work the subtraction problem out. Actually subtract through. Okay, welcome back. You guys should have found that you get, to do borrowing here, 23 and 7/10 seconds is how long Yuri took. Okay, so really, again, today's lesson was just on estimation and using that to help check your answers.